Malcure Transmission Terminal.
And this is Malcure Transmission Terminal.
Common signs of a hacked website. So depending on the kind of hack, there could be several. It could have manifest in various side effects. So for example, if you think about something which is redirecting the traffic, a malware which is redirecting the traffic, it is possible that it is only redirecting the search engine bots, and one of the results that you could see is when you search for that specific website in the search engine, so the result would be all, they would be botched up, and you would see some malicious titles or irrelevant titles, jumbled up text, maybe text in Chinese or Japanese characters and something like that. At other times, you may see the website becoming very slow because the malware is, so for example, there is the malware which mines bitcoins and cryptocurrencies. So that kind of thing actually hogs the CPU of the server as well as the browser itself. So users may notice that their browser is getting hung. When the browser gets hung, there's typically a client-side JavaScript that is, engaging the browser CPU resources. So that specific malware is basically utilizing the CPU of the user's computer and the browser itself. If there is a coin mining malware on the server side, it would be hogging the CPU and memory footprint on the server side. So in both cases, your website will appear to be slow. There could be other things as well. I mean, like you would see suspicious activity in the logs, that you could find your users complaining that I went to your website and I clicked on a button and it redirected me to some third-party website wherein there was malicious things or pop-ups, all those kind of things. So depending on the malware itself, it could manifest in a variety of ways. Now, one of the primary disadvantages or primary things which malware does is it affects your brand value. So for example, if your search engine results are botched up, so your search rankings will certainly go down, and it typically takes several months to build up that search authority again. Assume that you're a big known brand and you have this kind of a problem. Users come to buy something on your website and they land up on a malware infected website. So their user experience will be destroyed, and it also affects the brand value and the trust value. Like the next time they would not want to come on your website to buy stuff. So it definitely takes a toll on the goodwill, the larger public goodwill, the brand value, the SEO.
So like there are some terms that are flagged for being malware, like Viagra and Callus. But if there is a pharmaceutical website and they are dealing into that kind of thing, then how does Google or these malware, do you distinguish that it is within the range of malware or outside the range of malware?
So that's a good question, actually. There's no short 100% certain way of telling that something is a malware and something is not, right? It basically depends on the user's intention or the intention of the service provider. There, you would certainly find websites which are doing pop-ups and which are legitimately selling drugs online. There was a server in some European country. One of our clients came back and their website was about information relating to drugs and medicines and all those kind of things. So all the traffic they would get was looking for information about certain drugs. Now they got affected with malware, and it was highly targeted traffic because the same audience could actually be redirected and highly targeted to buy certain other drugs which were illegitimate or whatever. So in that case, it becomes very difficult. So there certainly are certain patterns, malware signatures that you can match sometimes, and most of the times, I mean, like they're made by human beings, so they're pretty accurate. But there is a good certainly a chance that a legitimate website may get flagged as malicious.
So you have been working on cleaning up websites for so long. So what is the majority of patterns you notice? Like, what is the root cause analysis? I understand that it is always different, but there might be some pattern that these kind of malware are more frequent or these are more common.
There's no such thing as common or uncommon. There are vulnerabilities which are exploited from time to time, and not everybody knows that there is a vulnerability already. There are hackers who typically try to exploit and discover vulnerabilities. So there are, it's called penetration testing. And when you land upon a vulnerability, the ideal thing is that, considering or assuming that you're a good guy, you would actually report that vulnerability to the software owner or author, whosoever has built that software. But often, when that information actually is discovered or passed over to the bad guys, they exploit that vulnerability. And depending on what kind of vulnerability is there could be different ramifications, different kind of malware, different kind of attack vectors. And that's how, certain days you would find certain kind of malware. At other times of the year, other times of the month, you'll find a different pattern to malwares or malware-infected websites. So DDoS stands for distributed denial of service. So when you say service basically means any kind of a web service, or it could be a service which is running on a server. It could be any kind of a service. It could be an SSH service. It could be FTP service. It could be a web server which is providing you services. It could be a update server which is providing you updates, right? So these are the services, examples of certain services. Now, what happens in an attack is when you any kind of a request that you make to the server, for example, if you're checking for updates, or if you're checking for WordPress updates, or if you were making a request to a server for a particular web page or a image or a video. So all these processes, even if you're accessing the web server, even if Google bot comes or any bot comes to index the website, it is actually accessing some kind of service from the website. So when it is accessing this kind of a service, there is certain amount of resource usage that goes into providing that service. There is some level of memory footprint, there is some level of CPU footprint that is engaged and allocated to serve that particular request. Now, what happens if you get too many requests? If you get too many requests all at the same time, your CPU footprint becomes extremely large. Your memory footprint becomes extremely large. Now let's assume that you have a reasonable size server like 64 gigabytes, something running quad core or multi-core, you have these servers that come in 16 cores these days. So a decently sized server. So such a server can actually accommodate for a lot of requests. But if someone intentionally sends you, let's assume, say, thousands and thousands of requests for a single web page, any HTML web page or a GIF file or even a 404 page. So due to that number of requests, there is a huge CPU and memory footprint associated with serving those requests, showing a 404 web page or showing a page not found kind of a 404 URL, whatever you've configured on your server. So this would actually increase the CPU and memory footprint. And if the number of requests is humongously large, then it would occupy the server, it would make the server busy. And that is what is called denial of service, that you're intentionally hogging down the CPU and footprint of a server to bring it down. Now, typically what happens is in a denial of service attack, you can actually track the IP address of where this attack is originating from. And accordingly, you can actually take preventive measures, put in a firewall, block that IP address, or whatever you want to do to block that certain kind of thing. But in a distributed system, what happens is this kind of an attack takes place over a distributed network. So one of the attacker could be attacking nodes could be in Japan, one could be in Africa, one could be in Russia, wherever. I mean, like they are distributed around a certain geographic area. It does not have to be worldwide, but typically it is worldwide. In such a case, it becomes immensely difficult to track down how many attackers are attacking you, how many attacking nodes are there which are attacking your servers. So that is called distributed denial of service. So when denial of service becomes distributed, it becomes distributed denial of service attack. And these attacks are slightly more challenging to handle. And one of the primary things people do to address this thing is while the security team is working to block those attacks, you actually have to expand your server. So these days you have these cloud services, so you either expand your CPU and memory to address these kind of attacks, other than the other security measures like you're taking to put in a firewall or identifying the patterns of attack and heuristically addressing and blocking those attacks. So that's distributed denial of service.
So even if you are using a CDN, does it help in any way, or it is of no significance in this kind of attack?
So when you're using a CDN, that means what basically is a CDN?
So content delivery network. So
Right.
Instead of coming directly to your server, it will be served through content delivery network.
So that again is a network, right? So basically the fundamental utility of a CDN is that when you're trying to access a web service, let's talk about web servers. When you're trying to access a website, so the website the request is made from a user in a certain geographical location, and when that user makes such a request, it goes to the CDN. So the CDN actually serves that request from the closest node in the network. So assume that my web server is located in San Jose, California, US, right? And there's a person in Japan who's making a request to my website, and assume that I'm on a CDN. So whatever closest node of the CDN is to Japan, the website will be served from there. So these things actually help a little bit in addressing these distributed denial of service, because one node can go down, second node can go down, and that is why you would find that most of the CDNs actually come with a built-in firewall. So the moment a node is overloaded or is supposed to go under a hog of CPU resources, automatically the firewall kicks in and they try to preemptively curb those network attacks.
That is why sometimes we see that I am not a robot kind of check when a site is served through Cloudflare.
So there are different settings, and it does not necessarily have to do with any kind of a CAPTCHA or this kind of a thing. CAPTCHA basically, typically, there is some sensitivity level in CAPTCHA which you can see, and there is some kind of an algorithm and even AI that plays behind these CAPTCHAs. So the moment they flag something as suspicious, they will show a CAPTCHA to identify whether it is a real user or not. And obviously CAPTCHA algorithms also come with their own pitfalls. Sometimes users are flagged as bots, so that is why they give you an opportunity to validate yourself as a human being. And if this is happening to human beings, it's pretty you can safely assume that it could be happening to bots as well. Maybe there are chances when bots are not prevented from accessing the web service.